In this video, I will begin with Algebra past paper practice for grade 10 to help revise for the upcoming Term 1 math exams. Here we have a question 1, and 1.1 says factorize the following expressions fully. Now when you look at the given expression, you need to identify the format that it is in so that you know the type of factorization to use. 1.1.1, we have 4y squared minus 16. Now seeing that 4y squared is a square number as well as 16, and there's a minus in between, we know that this is difference of two squares. So to factorize this, we are going to open up two brackets, and where we have 4y squared, we are going to ask ourselves, what times itself will give you 4y squared? Or, in other words, what is the square root of 4y squared? That is going to be 2y. So 2y times 2y gives you 4y squared. Then, where we have 16, we know that the square root of 16 is 4. So in our brackets, we're going to fill in 4 and 4. And remember that with difference of two squares, one bracket gets a plus, the other bracket gets a minus. So that is the answer. Now let's have a look at 1.1.2. We have x cubed minus 1 in the numerator. And in the denominator, we have x squared plus x plus 1. Now since we've got x cubed minus 1 at the top, that is in the format of difference of two cubes, because x cubed is obviously a cube number as well as 1, because 1 is 1 times 1 times 1. So they're both cube numbers. And we've got a minus in between, so this is difference of two cubes. So for now, we're going to focus on factorizing the numerator. To factorize difference of two cubes, it's important for us to remember that we have two brackets. However, the first bracket has a binomial and the second bracket has a trinomial. To get the binomial, we cube root the first term, so that's going to give us x. We cube root the second term, that's going to be negative 1. Now to get the trinomial is based on the binomial. To get the first term of the trinomial, we square the first term of the binomial. That's going to be x squared. To get the middle term, we multiply both terms together and we change the sign. So x times negative 1 is negative x. And when we change the sign, we get positive x. To get the third term, we square the second term of our binomial. Negative 1 times negative 1 gives you positive 1. Now there's something important that we notice. The second bracket with the trinomial matches the denominator. So we're going to leave this denominator as is. And in fact, you actually cannot factorize the denominator. It's one of those trinomials that you actually can't factorize on your own. Now, since the bracket in your numerator matches your denominator, they can cancel out with each other, and you are left with x minus 1. So that is your final answer. Now, for 1.1.3, we have x minus 1 plus y minus xy. Whenever you have 4 terms, immediately you should think about factorizing by grouping. So that's what we're going to apply here. So here's how factorizing by grouping works. We start off by grouping our terms as 2 terms and another 2 terms. And from here, we factorize each bracket. Now, since there isn't anything common in the first bracket, I'm going to leave it as is, x minus 1. In my second bracket, I notice that both terms contain y. So I'm going to pull out y as a common factor. And what I'm left with is 1 minus x. Now, at this point, you need both brackets to contain the exact same terms. However, my second bracket has the terms, but they're swapped around and their signs are different as well. What we can do to fix that is we can interchange those terms, keeping their signs. So it's going to be minus x plus 1. And we don't want the negative in front of x. So let's pull that out as a common factor. That's going to go in front of y when it multiplies with the positive. Positive times a negative gives you a negative. And inside the bracket, we are left with x minus 1. Now, this is what we need. We need both of these brackets to be the same as they are here. Once you've got both the brackets to be the same, you write it out once, and whatever is in front of the brackets, these terms. Well, in front of your first bracket, we don't actually see anything, so we take it as 1. And in front of your second bracket, you have minus y. So those coefficients in front of the brackets go in their own bracket. So we're going to have 1 minus y. So this is how factorizing by grouping works. Now this question was just a little longer than other questions usually are, only because we had the terms, but their signs were the opposite of what we needed. So we swapped them around, we pulled out the negative to the front. Once your brackets are exactly the same, you write it out once, and whatever is in front of those brackets go in another bracket next to it. So that is our final answer. Now we're on to 1.2, and it says simplify the following expressions fully. 1.2.1, in the numerator, we've got 3 minus 3x. In the denominator, we've got x squared minus 3x plus 2. So we notice that both our numerator and denominator can be factorized. Our numerator only has 2 terms, but they both have 3 in common. Our denominator has 3 terms, which is a trinomial. It's actually a quadratic trinomial. So that can be factorized as well. So in our numerator, both terms contain 3. Let's pull out that 3 as a common factor. Now in the first term, you're left with 1, and the second term, you're left with minus x. In the denominator, we've got a trinomial. So we know that when we factorize a trinomial, we open up 2 brackets. We are going to look at factors of the last term. When we multiply them, they need to give us the last term, and when we add them, they need to give us the middle term. Now 2 is a prime number, so its only factors are 1 and 2. However, when we add these values, we need to get negative 3, which means that both the 1 and the 2 need to be negative. So negative 1 times negative 2 gives you positive 2, and minus 1 minus 2 gives you minus 3. So in the first bracket, we're going to have x minus 1, and in the second bracket, x minus 2. Now at this point, we notice that the bracket at the top also has 1 and x, but they're actually swapped around. We need it to be x minus 1. So here's what we're going to do. We're going to interchange those terms. So we're going to have minus x plus 1. Now why are we doing this? We need to pull out the negative in front of the x, so that we can get this bracket to be x minus 1, same as the denominator. So let's pull out that negative. It's going to go in front of the 3, making it negative 3. And in the bracket, we'll be left with x minus 1. Now, what was the significance of this? We got it to be x minus 1 so that it could cancel out with the x minus 1 from the bottom. Now what we're left with is negative 3 in the numerator, and in the denominator, x minus 2, which is our final answer. Now we're on to 1.2.2, and just by looking at this question, we notice that x is the exponent. Now I have covered quite a few of these questions in my YouTube shorts. So after we attempt this question, if you feel like you need a bit more practice, please go ahead to my shorts and have a look at those videos. This type of question is something that is also tested in grade 11. So understanding it now really helps you build a good foundation for next year, since there's not much of a difference between the way it's asked now compared to grade 11. So here's what we have. And our first step is to rewrite all of the bases as products of prime numbers. So 16 can be rewritten as 2 to the power 4. And here's the thing, whenever you are replacing a base with its product of prime numbers, please replace it in a bracket if there is an existing exponent that goes outside the bracket. 12 is going to be 2 squared times 3. Its existing exponent goes outside the bracket. In the denominator, 3 to the power x, that's fine because 3 is a prime number. 4 we can rewrite as 2 squared, and the minus x goes outside the bracket. Now your next step is to get rid of all the brackets. So here's how we're going to do this. From laws of exponents, we know that if we have a to the power m all raised to the power n, we multiply the exponents together because brackets means multiplication anyway. So this is what we're going to apply so that we can get rid of all the brackets. So applying this with the first brackets, we're going to multiply the exponents together. So 4 times negative x is going to be negative 4x. Then here we have 2 times x, which is going to be 2x. 2 times positive 1 is positive 2. Now this 3 inside the bracket, we do not see an exponent on it, but we know that its exponent is 1. So 1 times x plus 1 is still going to be x plus 1. In the denominator, we have 3 to the power x, which stays as is. And we've got 2 squared, and that 2 is going to multiply with the negative x. So it becomes 2 to the power negative 2x. Next, we notice that in our numerator, we are multiplying bases that are the same. So we've got two parts here that have a base of 2. From laws of exponents, we know that when we're multiplying bases that are the same, we add the exponents. So simplifying that numerator, we're going to have negative 4x plus 2x, which is negative 2x, and then we've got the plus 2. So the base of 3 would stay as is for now, and our denominator would stay as is for now. Next, we are going to simplify the fraction as a whole, and we know that a fraction means division. What we also notice is that within this fraction, we are dividing bases that are the same. From laws of exponents, we know that when we are dividing bases that are the same, we subtract the exponents, where we have the top exponent minus the bottom exponent. So we're going to apply that here, and this is what we get. So we have 2 with the top exponent minus the bottom exponent. So we put this negative 2x in a bracket because there's already a minus in front of it. And here we have the base of 3. Here's the top exponent, x minus 1, minus the bottom exponent, x. Now let's just simplify this. So here's what we get, right? When we take this negative and we multiply into the bracket, it gives us positive 2x. But at this point, we notice that the minus 2x and the plus 2x cancel out with each other. And also, when we look at the base of 3 and we look at those exponents, x minus x cancels out with each other as well, leaving us with 3 to the power 1. Now what we're actually left with here is 2 to the power 2 times 3 to the power 1, and 2 squared is 4 that is multiplied with 3, so we get 12 as our answer. Now 1.3, it says given that m is equal to x into x minus y all squared, determine the value of m if xy squared is equal to 4 and x cubed minus 2x squared y is equal to 3. So here's the thing. You are given different terms and you're given their numerical value, which means that when we take the right-hand side of what m is equal to and we expand, if we notice any one of these terms, we can replace them with their numerical value. So if when we expand, we notice that we have xy squared, we can immediately replace it with 4. Or if we notice that we have x cubed minus 2x squared y, we can immediately replace it with 3, because after all, that is what the question wants. They want you to get the value of m. So we need to get an actual value as the answer. Now we're going to start off by writing down what m is equal to and working towards expanding it and simplifying. Okay, so here's what we're given, and our first step is to expand those brackets. We have a binomial squared, and we know that we can rewrite the bracket out twice and apply the FOIL method. So we're going to have x times x, which is x squared, x times negative y, which is negative xy, negative y times x, which is negative xy, and negative y times negative y, which is positive y squared. Now, before we multiply this x into the bracket, let's just simplify what we have within our bracket. We've got like terms, negative xy, that is going to give you negative 2xy. Now let's take the x in front of the bracket and multiply it into the bracket with all three terms. X times x squared gives you x cubed, x times negative 2xy gives you negative 2x squared y, and x times y squared is going to give you xy squared. Now here's something interesting that we notice. Based on the first two terms, x cubed minus 2x squared y, if we go back up to the question, we notice that the numerical value of that was already given to us. So we can replace those terms with just 3. And we notice that the last term here, x squared y, was given to us as well, where that was given as x squared y is equal to 4. So we can replace that part with 4. Now 3 plus 4 is 7. So we now know the value of m. M is equal to 7. We are now on to question 2, and 2.1 is based on solving for x without the use of a calculator. 2.1.1, we are given x cubed is equal to 9x. Now please do not divide throughout by x. If you're going to do that, you're going to lose one of your answers. So what I suggest is taking the 9x over to the left hand side. So we're going to have x cubed minus 9x is equal to 0. Remember, in order for you to solve for x, you like to have all of your terms that contain x on the left hand side of the equation. Now from here we notice that we've got common terms. Both of these terms contain x. So let's pull out x as a common factor. Inside the bracket, we'll be left with x squared minus 9. And what do we notice about the x squared minus 9? That is actually difference of two squares. And we know to factorize that, we open up two brackets. The square root of x squared is x, so we fill in x and x. And we know that the square root of 9 is 3, so we fill in 3 and 3. We know that one bracket gets a plus, the other bracket gets a minus. Now here's the thing about factorizing when you solve for x. Once you factorize, you equate each factor equal to 0. So we're going to say x is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. And they're actually quite particular about this. They want the word or instead of and. So it's always or in between your different values. Now, looking at the first part, we cannot further simplify this. So we see here that x is equal to 0. So that is one of our answers. But for the next equation, we can take the positive 3 over to the right-hand side. It becomes negative 3. So that is now an answer as well. And working with the last equation, x minus 3 is equal to 0. Let's take the minus 3 over to the right. It becomes positive 3. So we have x is equal to positive 3. Here is our three values. Now, You're probably not used to having 3x values as your answers in grade 10 or at grade 10 level. But here's something interesting to take note of. Your exponent of x, your highest exponent of x, tells you how many x values you can have at most. So if your exponent is a 3 where you have x cubed, it tells you that that equation can have at most 3 different answers for x. It's not always the case where you'll always have 3 if it's x cubed, but at most, right, there can be a maximum of 3 values. So here we ended up with 3 different answers. Now we're on to 2.1.2. We are given p is equal to 3 over 2x into p squared minus pq squared. Or actually pq squared minus p small q squared. Here they need us to solve for x. Now seeing that we've got letters like p, capital Q, small letter q, we're obviously not going to get a numerical value. Here they're just looking for you to make x the subject of the formula, meaning getting x alone on one side of the equation. So that's what we're going to work towards. Okay, so here is what we're given. And the first thing we can do is get rid of this fraction in front by... So there's a few ways you can do this. You can say that, okay, you are going to divide throughout by 3 over 2. That's one way of doing it, right? So your 3 over 2's on the right hand side will cancel out. And on the left, when you put that in your calculator, it's actually 1 divided by 3 over 2. So that's one way of doing it. But if you do it this way, what would you end up with? You'd end up with 2 over 3p. Another way that we can achieve the same answer is through cross multiplying. So to cross multiply, we can take this denominator of 2 and multiply it across with p. And we can take this 3 and multiply it with the denominator on the left. So there is no denominator showing, but p is actually p over 1. So the 3 ends up in the denominator. And what we're left with on the right hand side is x times this bracket. Now to get x alone, all we have to do is divide both sides by this bracket. Now obviously when you divide the right hand side by the bracket, it falls away, cancels out. But when you divide the left hand side by the bracket, it's going to end up going in the denominator. So it's going to end up here next to the 3. So that is what x is equal to. Well, if you'd like, you can actually swap this around, put x on the left hand side, put this big fraction on the right, but it means the same thing either way. We have solved for x here. We've managed to get x alone, meaning we've made it the subject of the formula. Now 2.1.3, we are given 3x to the power 3 over 4 is equal to 81. So let's start off by dividing both sides by 3. On the left hand side, the 3's are going to cancel out. We're left with x to the power 3 over 4. On the right hand side, 81 divided by 3 is 27. Now you can actually rewrite the 27 as a product of prime numbers. That is going to be 3 cubed. Now we need to get x alone. And what we notice is that we have a rational fraction. Remember, rational means fraction, right? We have a rational exponent. So we have a fraction exponent. And when you need to cancel out a fraction exponent, all you do is you multiply by the inverse. So if we swap this fraction around, we're going to multiply both sides by 4 over 3. So what happens on the left hand side when you have 3 over 4 times 4 over 3? They cancel out to give you 1. So essentially you have x to the power 1 on the left hand side, which is just x. And on the right hand side, if you have 3 times 4 over 3, you're going to be left with 3 to the power 4. Now 3 to the power 4 is equal to 81, which means that therefore x is equal to 81 is your answer. And also here's something to remember. If ever you're solving for x and you feel like your answer looks a little weird and you're not sure if it's right, all you have to do is take the value that you got as your answer, substitute it in the question in place of x. So if you substitute 81 into the given equation, the original equation, on the left-hand side, you would have 3 times 81 to the power 3 over 4. It should give you 81. So the good thing with solving for x is that you can always check if your answers are correct. Now we're on to 2.2. It says solve for x if, and in 2.2.1 we have 3 into 2 minus 3x is greater than or equal to 15. So here we have an inequality question. So here's what we're given. And we know that to solve for x, we need to fully simplify this. So let's first start off by taking the 3 and multiplying it into the bracket. We get 6 minus 9x. At the same time, we can, actually for now, let's just leave the 15 on the right. It's actually easier this way. Now, the next thing is we're going to get the minus 9x alone on the left. Let's take the 6 over to the right. So it's going to become a negative 6. 15 minus 6 would give you 9. Now, another thing to remember that when you are doing inequalities, you always have your term with x on the left. Don't ever take it over to the right. So keep it on the left. Even if it's negative, it's fine. At this point, we want to get x alone. So we are going to divide both sides by negative 9. On the left-hand side, it cancels out. So we're left with x. But there's something to remember. You learned way back in primary school, when you were first introduced to inequalities, that when you divide by a negative, the sign changes. And that rule still applies in grade 10. In fact, it applies all the way up until matric. It never changes. It's quite a cemented rule in maths. So we're dividing throughout by a negative. The sign's going to go from greater than or equal to becoming less than or equal to. And on the right-hand side, 9 divided by negative 9 is negative 1. And that is your final answer. Now 2.2.2 says hence, and we know hence means that it's based on the previous question. So we're going to use our previous answer to do this. Represent your answer to question 2.2.1 on a number line. So here's how we do this. We draw a number line, and it's not necessary for you to represent all the values. Represent the value that you had in your answer. You draw a small circle above that. And since this answer had an equal to, we're going to shade in the circle. Now our answer represents all the values that are smaller than negative 1. So that's going to be negative 2, negative 3, negative 4, all the way up until negative infinity. Basically on the number line, or think of your Cartesian plane, your x-axis, that is representing values to the left of negative 1. So when we draw our arrow, it is going to go to the left. So that is actually it. And the last question we have is to solve simultaneously for x and y. So we have 3x plus 2y is equal to 13, and 3x is equal to 2 minus y. So here's what we're given, and to start off, it's actually easier to work with the second equation, because here it's a lot easier to make y the subject. So let's take y over to the left to make it positive. Let's take the 3x over to the right. So right now, we know what y is equal to. Y is 2 minus 3x. So we're going to take this for y and substitute into the next equation. So here's what we get. Where we had y, we replaced it with 2 minus 3x. Now let's simplify this. We're going to take the 2 and multiply into the bracket. It's going to give you 4 minus 6x is equal to 13. Let's gather like terms. 3x minus 6x is negative 3x. Let's take the 4 over to the right. We have 13 minus 4, which is 9. To get x alone, let's divide both sides by negative 3. On the left, it cancels out. We are left with x is equal to negative 3. And now that we know what x is, we can take this value for x and substitute into the next equation to get y. So doing so, we have 2 minus 3 into negative 3, and simplifying, we get 2 plus 9. So y is actually equal to 11. So here we have it. We have solved simultaneously for x and y. So if solving simultaneously for x and y is something that you struggle with, I have posted a video previously where I've worked through 5 past paper questions based on solving simultaneously. So if you need a little extra help on this, or you just want to revise, please make sure to check out that video. Please remember to like, subscribe, and turn on your notifications for more content.